Welcome to the Trending XR podcast, where we discuss the latest in augmented reality, virtual reality, and AI with industry leaders who are shaping the future of how we will work, socialize, and go about our daily lives in the third dimension. In the not-so-distant future, we won't even be using phones. We'll be using these. I know, sounds crazy, but we have never been closer to this future concept becoming our current reality. I am so excited to share this new world with you. I hope to teach you, inspire you, and ignite your passion for extended reality. It's time to change dimensions. Are you coming? Welcome back to the Trending XR podcast. Today's guest works in the 3D, computer vision, and computer graphics industries. He is a pioneer in 3D GS and 4D GS and is personally responsible for some of the early breakthroughs in these spaces. I'd like to welcome on Martin Piala.
Thank you very much for having me.
Yeah, I'm super excited to talk about this. So Martin works in the 3D computer vision and computer graphics fields, but predominantly right now working in the 3D GS field, which is 3D Gaussian Splats. Is that right?
Yes, yeah, that's correct.
Which is a fascinating field. If you've watched the podcast before, we've had on three pretty cool people in the same space that have gone into great lengths about the radiance field industry, and we've been kind of like off the air on 3D GS for about 6 months now. So like a lot's happened in this field. This is particularly like AI. It's like one of those fields that is just like rapid firing out, like big advancements every month. I know there's a lot of white papers coming out. So there's a lot of people getting interested in the field and coming up with really new, cool things to push the ball forward in 3D GS, radiance, and radiance fields. So I'd like to kick off most podcasts with asking the guest to tell us about like their story. What's the unique Martin Piala story where maybe you stumbled into 3D data capture or radiance, and how'd you end up there? Like what's the story there?
That's a good question. I think it was like a series of coincidences, and series of like random events that led me to, as it usually happens. So I've always been really interested in computer graphics. I was always really curious about like how does it even work? How is it possible that rendering engines can take the 3D model and make a image out of it? I played a lot with Blender, just like ages ago. So I was always a little bit curious about this space. Then I decided to study computer science because I also like programming, I like software engineering. I studied computer science here in London, and I basically took all the possible modules for computer graphics and computer vision because those topics were still kind of interesting to me, and I was just genuinely curious about them. No other thoughts. But then in my final year, as I was working on my master thesis, I had to choose what I would be doing for my master thesis, essentially. And I stumbled upon a few papers in the computer vision, computer graphics direction. And luckily also with my supervisor, we decided to look more into back then it was neural radiance fields, the original NERF paper that came out in 2020, I think. So we looked at that, and there's like a lot of room for improvement. So we try to essentially speed up the original rendering pipeline. For context, back then it took a few hours to render like just a tiny image that was like 400 by 400 pixels. So yeah, it took a lot of time. So there's like a lot of room for improvement to make this like more optimal. So I worked on that for a year. I learned a lot about neural radiance fields. I re-implemented the method probably like 2 or 3 times, and also like all other papers that came out during that year. And yeah, essentially in the end, I sped up the rendering pipeline around 14 times. Even like after that, I finished my master's degree. I worked on the method a little bit more over the summer, and we published a paper out of this, which was, funnily enough, like a state of the art for a few weeks, for a solid 3 or 4 weeks. But this kind of like shows how fast moving the industry really is.
It's like 8 years in radiance.
Yeah, exactly.
It's like dog years.
Yeah, exactly as you say. So for solid 3 or 4 weeks, it was state of the art. But then like a new paper was published that like sped it up even further. But yeah, it was the method to render NERs faster. And I think since then I stayed in the industry. I was always curious about this, and I wanted to continue doing it. I kind of saw the potential of the method, even though even back then I knew that nerfs are most likely not the technology, but I knew it's going to be something in that direction essentially. So I was working as a software engineer. Since then, I was working as a contractor, then built it into like a smaller company over the few years. I focused both on like a general software engineering projects, as that's basically still my craft. But I took on a lot of computer vision and computer graphics related projects. I implemented a few nerve pipelines and then later on Gaussian splatting pipelines for companies that needed it for their own niche purposes, etc., etc.
Okay.
Basically, was working on these kind of jobs. And now I'm also founder of Blurry, which basically brings us to this time today. I decided to build my own company and build my own product around Gaussian Splats because I think Gaussian Splatting has a lot of potential to be the technology to create good digital twins. So I decided to go for it and build a product around it. So yeah, I'm building Blurry right now, which is a platform to host and share 3D Gaussian splatting models. So the idea is that you just come as a customer, upload your model, you get a link, you can share with anyone or embed. So yeah, that's really
I
my
checked
story.
it out. It's really nice.
Thank
Yeah, it's
you.
great. Thanks for sharing that. Yeah, the site is really nice. I like the UX and UI on there, and
Thank
it's
you.
really affordable. I was looking at your subscription ranks, and I was like, oh, that's pretty fair. Yeah.
Thank
It's
you.
got some pretty cool tools on there too. Yeah, and I'm not a 3D GS guy. I just like I'm interested in it, and I know that you got some really cool features on there that I think people who are into this space would really like.
Yep.
So if you're interested in that, I will plug that into the podcast details so you guys can go check that out.
Thank you very much. Yeah, very much appreciate it.
Yeah, what's your goal with Blurry? Do you want to keep expanding that and kind of adding out more features, or is this more of like just where it is right now is kind of where you want to keep it? And
No, I definitely want to expand it. I can tell that like a new shiny Gaussian Splatting studio is coming out on Blurry. I can already share that.
oh,
I'm already testing that.
neat.
So there are like a lot of new features coming out. But basically, the idea with Blurry is that it should be the place to go to if you want to share your Gaussian Splatting models online. The big problem with Gaussian splatting models is that no browser can render them. Like they're like very
Mm,
niche file formats. No browsers know how to render it. So you need like a
okay.
dedicated tool to do that. And I want Blurry to be the go-to tool to share and visualize these splats in browser. So you might want to embed it on your website. You might want to share it with your audience, your clients, your customers via a link, stuff like that. So that's what the Blurry should be for. And if you want to do
Okay.
some editing of the models, you should be able to do that in the tool.
So
That's
right now
that's kind of
that's
like,
really
yeah.
right now that's not really a thing. So how do I guess what is the way that you share them right now? You have to do this over like a Dropbox link or something, or
So you could do the Dropbox link, but the issue with that is that your client will need a dedicated software to then download the file and see what's inside the
I see
Gaussian
what you're
Splat. So
saying.
that doesn't really
Yeah,
exist. Like these tools
yeah,
don't really
I got you.
exist. Like there's a big gap in the tooling essentially. Um,
Yeah, same problem we have in like the 3D modeling world. You try to open like a .blend file or something. It's like you have to have Blender
exactly.
to open it. Yeah, I got you. Okay, cool.
Yeah,
That's
exactly.
great. Yeah, that's gonna help people
So
out a lot,
so
especially sending stuff to people who have no idea, like me, how to like play around with a 3D GS file.
Yeah, exactly. Like it would be kind of like you would have to go through a lot of pain to explain to your customers and clients, like, oh, to see this file, you need to go through this hell and torture to install these 4 different pieces of software, and it's going to take you 4 hours. So yeah,
Which is
this
usually
way
a
just get a
big
link.
Yeah, it's a big problem in like it's like VR, any technology you're trying to get people who aren't super tech savvy to use. It's like as soon as there's this little like bit of friction, they're like, I'm out. So I think
Yeah,
solving that problem there is a smart move. But
I
that's
think
great.
yeah,
Thank you for sharing it.
yeah, no worries. Yeah. Yes, I think we're in the very early stage of this new technology, and so far it's like
Yeah.
these enthusiasts that are like picking it up. But as it gets more approachable by other people, we'll see like mass conversion there.
Yeah, I think that kind of like leads us right into a great question about 3D GS that you propose we talk about. And that is what makes 3D GS particularly suitable for creating digital twins, opposed to creating full 3D mesh models, which is
Hmm.
like the standard of the past. You know, we're moving into this new way
Yeah,
of doing things. What does that look like?
yeah. So the big advantage of Gaussian splatting is that it can recreate a photorealistic looking digital twin just from images or videos of whatever you are trying to digitize. You know, it can be car, it can be your apartment, it can be almost anything. And it recreates this really almost realistic looking digital model of whatever you captured. In comparison with Mesh, which is easy to render, easy to work with, and we know exactly like how to work with polygon meshes today. We don't have the methods to create a polygon mesh model out of images and videos, or more precisely, the methods that we have right now don't really work that well, and the output is well, it doesn't look great. So we have photogrammetry, which is very common, which is really good for really precise geometry, but it doesn't look realistic. So kind of like a polygon mesh is a little bit like out of the question unless you want to pay 3D graphic designers and 3D artists to recreate the 3D model from given reference,
Right.
which might be just too expensive. And maybe the reason why Gaussian splatting is really good in comparison to other similar, what we call them, novel view synthesis approaches, is that we can render Gaussian splatting very efficiently on our hardware today. So, for example, in comparison to neural radiance fields or any kind of a neural volumetric rendering approaches, we can render Gaussian splatting very efficiently because we can, with a few little hacks, we can kind of translate them to a polygon, almost a polygon-like model, which our GPUs, graphic processing units, really like, and are basically built to render. And that's what makes them really good for representing the world. They're like best of both parts, good at digitizing what you have, and also very fast to be rendered on modern devices, even on like mobile phones and stuff like that.
Yeah, very important. So yeah, I think like the boil down of that is that it's more data intelligent. You know, we're not having these massive mesh files like a standard 3D model has, you know, millions of polygons, and it's heavy. It's heavy, and it takes a
Yeah.
lot of compute to push that through a device, whether it's a computer or getting into extended reality devices like AR and VR.
Yes.
You know, and
Yes.
that's particularly important because like in AR, because that's on the go, and they're smaller, so the compute capacity is in terms of hardware is smaller. So how do we, you know, I know edge compute is something that also can help in that field. So how do we get all of this data to look very realistic and able to be computed very quickly onto mobile headsets? Which is like jumping ahead a little bit to our next topic here, but you know, it dumps in just perfectly. If you want to maybe just go right into that, I think that's a pretty good segue on
Um,
the using 3D GS in AR and VR applications.
Yeah, so exactly as you said, it's very important to be able to render 3D GS very efficiently. Exactly as you said, with VR, AR headsets, you are limited in compute, you are limited in power, battery life, all that stuff. So you can't really afford to be rendering massive neural networks and other weird not really compatible formats like nerves on a VR device. So we need to go into something that leverages basically last 30, 40 years of hardware research in GPUs. So this is maybe like an interesting story of like how we ended up with polygons, and then I will go back now into how it
Yeah,
ties
sure.
with Gaussian splatting.
Great.
So basically, back in the 1970s, 1980s, when mesh polygons were starting to polygon meshes were starting to become a thing. People started to use them to create 3D worlds, for games like movie effects and stuff like that. There was like a really strong positive feedback loop between meshes and the hardware that was used to process them. We knew how to render meshes. Therefore, GPU companies like NVIDIA, Sony, etc., they came up with a dedicated hardware, we call them GPUs today, to render them more efficiently and faster, so that we could render bigger models and have more frames per second at higher resolutions, etc., etc. And that basically led to even more people using meshes because suddenly it was easy to render them, which prompted the GPU companies to make better GPUs, etc., etc. So there was like a really strong positive feedback loop between these two, between the mesh representation and the hardware. So we went through 40, 50 years of research into really good hardware that can multiply all the matrices as we need them to render polygons. And that's where Gaussian splatting really excels at. You can kind of, quote unquote, convert Gaussian splats into polygons almost. That's how some rendering engines render them, and you can basically rasterize Gaussian splats utilizing this 40 years of research into rendering them faster, essentially, which is really necessary to render them efficiently on mobile devices, on remote devices. You take this like 3D model that you have in some space, and you want to flatten it out into the camera space. Like, what does this thing look like from this particular angle? And this is not really possible with representations like nerves or occupancy grids, etc. But it is possible with Gaussian splats because we know ahead of time where all the Gaussian splat positions are. So we can kind of hack them into this rasterizing pipeline. And the way it really works, like most modern rendering tools for Gaussian splatting, works in a way where instead of rendering each splat, which is essentially this like tiny three-dimensional ellipsoid or a ball in space, you convert it into like a flat square or like a flat rectangle, and project that sphere onto that flat face, and then you basically collapse all the faces into the camera. So you are kind of hacking the rasterizing pipeline into rendering splats.
Yeah, so it's kind of just like a converting the use of this hardware from like and kind of like keeping some similar pipelines of how they like operate to function more for Gaussians instead of for meshes. That's cool. That kind of like it makes you like think. I'm a frequent thinker, like forward thinker on AR and how does this all come together? We're gonna have like, I don't know, Meta will have one, Google will have one. I'm sure there'll be a few players in the space for AR headsets, for glasses, lightweight glasses. And we'll be walking around in the world, and you'll walk down the sidewalk and you'll come up upon a 3D model of something, whether it's an experience or it's a menu for a restaurant or a billboard or whatever, What is that? How does that, who owns the map, and what sits on those maps, and how do you experience that? Is it going to be a Gaussian splat because you're going to move around it? Can Gaussian work for that, or does it have to be a mesh model that's presented through these glasses? It's curious to kind of think, or interesting to think about where that's going to land. How's that going to all function live in the real world?
I think because you can utilize this, as I mentioned, rasterizing rendering pipeline, the rendering pipeline that we know of, that we use normally. You can utilize that for rendering Gaussian splats. I can imagine that the world that we will live in, the AR world, the VR world that we'll experience, will most likely be a combination of the mesh and the Gaussian splats. And the reason being is that there is no reason for it not to be a combination. Why not
Sure.
use the best tool for the purpose? And if you want to display the best, display a digital twin of something, of a restaurant, of a venue you are doing, I don't know, a remote viewing of, for example, that can be a Gaussian splat. But if you want to overlay some extra information on top of it, maybe you are viewing what your future living room will look like based on some architecture visualizations. Why not capture your current living room as a Gaussian splat and insert some 3D meshes into it to see what it could look like, made by
Yeah, that makes
3D
sense.
3D
Yeah, kind of
artists.
marrying the two.
Exactly. Why not combine these two? That's basically what utilizing the original rasterizing pipeline allows us to do. We can combine these two things kind of efficiently. Yeah.
Yeah, that's nice. I think that's maybe good to hear if you're like someone who doesn't know about the radiance field, but you kind of like heard of it, like, and you're like a 3D modeler, and you're like, oh no, am I like out of a job? You know, it's like, no, I think
No.
yeah, you're good. I think you're good. I think they're gonna work together in ways that they both scratch an itch, right? Does
Exactly.
that
Yeah.
dump us into like a good segue for 4D GS, which I know basically nothing about, which I'd love to hear about.
I think so. So one of the limitations, current, like you just touched upon it. One of the limitations of Gaussian splatting is that it can only represent static scenes that don't change. But that's not really how our world is like. If you want to capture anything outside, there's like a huge pain because trees are moving in the background because of the wind. People are walking around you. There are cars moving. All this stuff. There's like a dynamic aspect to the world that we live in, which
Yeah.
current three-dimensional Gaussian splatting can't really deal with. It relies on the fact that your scene is static, and you take a couple hundred pictures of whatever you are capturing, and for that capture, everything has to stay the same. Even the light has to be the same. It can't really change too much, even though there is some research on like how to cope with differences in light.
Yeah.
But otherwise, no big movement. And that's where kind of like a 4D Gaussian splatting came out, or like where this idea of like four-dimensional Gaussian splatting comes from. It's basically, I mean, the best way to describe it is moving Gaussians. You capture the fourth dimension, which is the time in the Gaussian splats, and you allow them to move over time, and you can basically play them back as it's almost like a three-dimensional video. There are like a few companies currently popping up that are trying to do this. And the way this really works, like the best way to capture these kind of scenes is in a studio with like a huge rig of maybe 30, 40, 50 cameras all
Hmm.
around, and then you do your thing in the middle. You capture the scene from all the angles at once. You basically take a video of it, and then based on that, you can train a moving Gaussian splat that you can then play back and view from any angle as it plays out. I think that's a quite hot area of research these days, especially because it adds this kind of like extra level of immersiveness. I don't have a better word for it, but it becomes way more interesting to suddenly watch something move, and I think this could be a really big thing for AR and VR, because suddenly you can walk around, people cooking, people dancing, things moving actually. So yeah,
Yeah, this sounds like
that could be a really big thing. Yeah.
yeah, that sounds like maybe a really big that might be a really big revolution for the media industry, like how we
Hmm.
experience a movie. Like you can kind of walk through it as it as it goes along in the story in the
Yeah.
space, which is crazy. I mean, there'll probably be like dedicated facilities in the future maybe where you
Hmm.
go and like going to see a movie and you can go walk through a movie. I think that's a really
Yeah.
interesting just use
You can
case for that.
step into the scene as if it was like a, I don't know, live theater or something. Yeah.
And it being, I guess like is that like novel view? Like if you're like moving through like 4D GS, I guess you're capturing all angles. So you're kind of like able to walk anywhere you want, and it will kind of adjust your screen, like what you're viewing. Like the Gaussian will adjust, or is you're just seeing the Gaussian from that particular spot, I guess, or is it like jump points? Do you think it's going to be like you'll be able to walk, and no matter where you're looking from, it'll look normal, or is it more of like jump points where you have to be in like a certain spot where like the camera's shot?
I think the first one, you should be able to freely walk around, and as long as the viewing angle that where you are standing and like viewing the scene from has been somewhat captured, at least from like a similar positions, it should look normal. It should be truly like a moving Gaussian as we are used to right now. The same way you can view a static three-dimensional Gaussian, imagine the same thing but moving.
That's pretty cool.
Yeah.
That's gonna be really interesting.
Yeah, I've seen some early demos already. Maybe I can share some links afterwards. I've seen some early
Yeah, I
demos,
can
and
share
it's
it.
really, really impressive of what it can look like. Um, I think the research is not 100% there yet. It's also difficult to capture because you need tens of cameras,
Right. Yeah.
all
It's expensive
capturing
at the
everything
moment.
synchronously, and then you get a lot of data to process. But this is slowly becoming an engineering problem rather than a research problem. Like we
Yeah.
already kind of know how to do it. We just need to build the technology around it, if that makes sense.
Yeah, that's pretty cool. I think that dumps us into a really fun conversation, which is like generative worlds. And
Yeah.
I wanted to like kind of ask you about how AI has its play with the radiance field tech, because I think that
Mm-hmm.
those two are gonna dance really well together.
Mm-hmm.
And curious kind of like maybe where that's at now, if you know anything about how AI is influencing the space, and then we can get
Yeah.
into generative worlds too, which is pretty wild.
Yeah. Yeah. So I mean, there are new kind of like technologies popping up and new companies coming up, like Genie 3, which was recently released by Google. There's this
Right.
company called, I think, World Labs. That are trying to build these generative worlds
Mm-hmm.
that you can
Yep.
walk through automatically. And it's very interesting piece of technology. It's well, we don't really know how exactly it works. To be precise, we can only speculate from
Sure.
other similarly looking models, especially the ones that are used to generate videos. Uh, they seem to work in a very similar way. Um, then that's how we can like basically speculate of like how these generative models to generate world work. I think people start calling them these like large world models instead of like large language models because they work on the same underlying technology, like very similar one.
Mm-hmm.
They basically utilize these like transformer models and look at all the frames of whatever you have generated so far as like a sequence and try to predict the next image in the sequence based on whatever action you have taken plus whatever prompt you gave it. And the prompt can be either a text or an image of your scene. Like, okay, you can give it an image of your living room and tell it, oh, I want to generate a 3D world from my living room based on this image. And it will go ahead and generate it, and you can walk through it. It might not be 100% precise because there are some hallucinations. Plus, there's only so much information you can figure out from
Predictions too.
only one image.
Yeah,
Right?
it's
It's
got to
like not,
guess. Yeah,
yeah, it kind of has to guess, but it has a lot of promise that it will be good enough for
yeah.
most applications, which is really cool. And I do hope that it will get better over time, obviously. But I think Gaussian splatting and NERS will be used mostly as a way to train or like generate data to train these larger models. So that is my prediction. I might be wrong, and as most predictions in the AI world are, this will most likely be wrong because the field is moving very fast and very very chaotically. But I do think that we will use Gaussian splatting and nerves basically to enhance these large world models, which will be the way to generate uh, environments from pictures and videos and text prompts. Um, Yeah, that's what I think is going to happen. And the reason for that, this is quite interesting. There is there's an interesting essay that was written in 2019, I believe, by Rich Sutton. It's called The Bitter Lesson. For those who don't know, Rich Sutton is basically considered the founding father of reinforcement learning and in general, a very influential person in the world of machine learning. And basically, this essay, even though it's not like formal paper, it is considered a canon in the world of machine learning and like among machine learning and AI scientists. And the idea is that every handcrafted heuristic or every handcrafted rule will eventually be outperformed by just better compute and better search. And this has been proven over and over in the world of machine learning. I think the best example, for example, is are basically chess engines and how they started off with a lot of rules created by people who had loads of domain-specific knowledge in chess. They knew how to play chess. They created all these tiny rules of which piece has what score and how to evaluate the board, and that was all baked into these chess engines. And these were all eventually outperformed just by better search, deeper search, which is like looked through more positions in chess. And a similar idea applies to almost any other area of machine learning. In computer vision, we first started, for example, with some handcrafted rules and handcrafted algorithms to extract features from images so that we can identify the same features across multiple images and cross-reference them and figure out what is it exactly we are looking at and maybe classify objects in images. And a lot of these features were at first handcrafted by really, really smart people, and all of these methods were, fortunately or unfortunately, outperformed by fully learned approaches, basically based on convolutional neural networks and fully learned on a lot of data. So no more handcrafting, just like loads of compute and loads of search that was thrown into the space. And I think similar thing will most likely happen to the world of Gaussian splatting. Eventually, it might come in 10 years, 20 years, don't really know. But if you think about it, Gaussian splatting is very smart and clever heuristic, or is a very smart and clever handcrafted rule that the world consists of a 3D matter and can be represented as these tiny splats, and that light travels in straight lines. Those are the rules that are baked into the model. And I think eventually all of this will be outperformed just by a huge base model, huge like fundamental model that can learn how the world works and can generate it just fully internally based on loads and loads of data it has seen. But when is this coming? I don't know. This is just like a long-term prediction of what I think might happen and the reasoning why it might happen.
Yeah, that backs me up to a question I had a little bit earlier, which was we were talking about like AR and how Gaussians and how 3D meshes are going to work in that lightweight AR glasses, everyday use kind of space out in the real world, right? And you were talking about like lighting, and you're talking about how light travels in one direction, and that's kind of like data that's baked into these Gaussians. Will there or is there maybe already some form of radiance where it's a reactive Gaussian to its current environment? So say you have glasses and they're reading, sunlight and shadows based on what you're looking at. Will that be able to be on the fly transferred to models to change the lighting so that any model can be placed in any environment and react accordingly to what's actually happening out in the real world?
I think this is one of the areas of research that we still need to dedicate more effort into, if that makes sense. There are approaches that let you edit the Gaussian splatting models, but it's kind of clunky, difficult, and if you start editing them, it doesn't look realistic yet. So we'll need to spend more time and effort into figuring out how to do it research-wise and technology-wise, and then B, how to build tools around this knowledge so that it's easy for people to edit these models, create models in different lights, different lighting conditions, edit them, recolor them, etc., etc. There are some papers, there are some ways to do. I think there's like a Gauss Studio, which is quite popular from ETH that came out I think last year, something along those lines. It was like one of the biggest ones that let you basically prompt the Gaussian Splat like with text. I want to change this part
cool.
of the model, change the color to blue, to red, or paint it differently, etc. It does work, but it is pretty cool. It is pretty cool, but unfortunately, it still kind of like loses this visual fidelity, and you can suddenly tell there is like this like CGI look to it, which we don't really have with. I think these methods just need to get better. I think these methods just need to basically ingest more data and understand what it means for the light to change. Because if you think about it, sorry.
I was gonna say like the operation's still the same, right? So it's still creating like the same splat, and like it's the way that it is making it is the same. What exactly I guess is like where that fidelity is lost? Like what is the problem? Like what's there? Is it just like a lack of putting information in the right format? Like and it's like it just looks weird, or I mean, and if you don't know the answer, that's fine. It's like this is like a novel thing. So
no worries. The issue is more that the Gaussians don't really understand the light transport. They don't really understand what shadows are, what is the color of the light, etc. All of this information is baked into the color of the Gaussian itself, of the model itself. It is as if you had a 3D model, and instead of like using lights to create shadows and bright parts of your model, etc., you just used pure textures and say, oh, on the left, this part of the model is brighter, on the right is darker, and just make an illusion of a shadow and light and what it looks like. That's exactly what's happening in Gaussian Splatting. All of that light, all of those shadows is just an illusion and is baked into the model. Yeah. And if you want to change it, you need to know how to recreate this illusion, which is very difficult problem to solve. You don't need to solve it for the original model because all of that information is in your original capture, in your images and on all the pictures that you have taken, right? Like that information is there. So you just recreate that illusion. But if you want to change it, you need to know how to recreate the illusion that makes it look real.
I think this is exactly where AI and Radiance merge and like figure out that little solve there, because it's all I'm like the way you're explaining it, all I'm hearing is that it's just misclassifying information so that it's just not presenting it properly. So I think with AI is like we were talking earlier, like generative worlds where it's like it's predicting, it's guessing, but it's guessing really well and it's getting really good at guessing. I think you just merge Radiance and like a really intelligent large world model, and it's gonna have that training data set to understand, change the flower blue. This is how the light should work on a flower that's blue, etc.
Exactly.
I think we'll get there.
Yeah.
I don't think we're that far off either. I think like 6 months.
We're always 6 months away from the AGI. Like whatever the time is, we're always 6 months away. But yeah, I do agree with you. That's what I meant. That we just need models that are better, that are trained on more data, that generally understand what it means for the light to be coming from the left, from the right, from the top. They understand how the world fundamentally works, and they have seen all those examples. So now they can recreate all those illusions by generating either new Gaussian splatting models or modifying the ones that we already have. So I think you are exactly spot on. We just need the better models that understand how the world in general works and can edit them.
Yeah, I'm curious what we're gonna do with all this. It's like we're building all these like it's like, wow, we've achieved creating a whole world that you can navigate. I don't think we like specifically defined what generative worlds are for someone who's listening who has no idea what we were talking about. Basically, it's like using AI. Like you've created an image, where you'll go in, you'll type in what kind of image or world you want to experience. So if you want to experience like a rainforest world with mountains. You know, like you'll explain these things that you want to see, and it will generate like a video game where you can explore it in any direction. So you'll have the ability to walk around or fly through it. And this is like something that exists right now. So that is just like this incredible breakthrough in technology. Like, what do we do with this? Like you have just created the ability to create a world, whereas before someone would have like modeled that by hand to like as a video game experience so that you could have all this data to explore. But this is being done now just by generative means with AI. So what's the use case for this outside of like doing this, just flying around in this like made up space? Or video games, like how can we use this creatively into the future? It's like a big question for me. I don't know if you have any cool ideas that you've come across.
I've seen several use cases of like how people use these models already at Blurry. So I can tell you a few ideas, but I think for the generative models, the most obvious one is entertainment and games. The same way people play computer games, like why not generate the same world, but have it all generated by an AI and have your own personalized computer game? That's one use case. Another really big use case is for film industry. So today, a lot of the shots for movies, they are done in studios. In front of like huge LED screens, and they project whatever scene or place the actors are supposed to be in onto the LED screens. I think Dune was shot like this. There's
been a few, yeah. I work in the film industry, by the way. I don't think I briefed you on that, but
really?
I did very big movies for like 5 or 6 years. Yeah, so like yes, you're right. Like the LED volumes is like predominantly that, or big blue screens is another way that we do that as well.
Exactly. So that will be like a big time. Like you don't have to transport, or like you don't have to make all the actors and all the crew travel to the location to shoot there. You can send like 1 or 2 people there, capture everything, bring it back, and then bam, you have the whole scene only in your studio, and you have the perfect golden hour for as long as you want. You are not constrained by, we have only 30 minutes of this golden hour for this perfect lighting, and we have to come back tomorrow if we don't take all the shots. Suddenly you have all the time you need to finish it. Those are like the very obvious approaches, but there are like very obvious kind of like ways to use this technology. But there are like some maybe less obvious ones. Quite a big one on Blurry currently is also like a professional training. So imagine you have some crazy difficult piece of machinery and you need to train engineers on like how to use it, how to operate it. Or maybe you have an ambulance or firefighting truck. And there are all these like compartments where you have your equipment, and all these people, firefighters, paramedics, etc., they have to be trained on how to use their own equipment, because it can be quite complex. There's like a lot of moving parts to every piece of equipment they use, every tool they have. And the way they do it today is just by looking at images with descriptions. And then once they have the idea of like what it looks like, they are brought to like a real ambulance or a real fire truck when someone shows them like, oh, this is where you find this, this is where you find this, this is how you operate the whole thing. And there is some level of interest in creating 3D models out of all the tools and equipment they use, so they can use it for like virtual training, like more immersive way to train people and make them better without having to bring them in person to the real thing. I mean, eventually they will have to see the real thing, but if this makes them better and more efficient learning how to use everything, that's great. And same goes for any piece of machinery. So this is like an additional interesting use case that I have not realized until I actually built Blurry, and people started like asking me like, how can we use it for that?
Yeah, no, it's fascinating. I actually just talked to someone. I just remember this. So I just did a podcast with someone. It's not out yet, but he is using 3D generative worlds for like HDRIs, and they're using this for therapy reasons. So like if someone has a fear of heights, or fear of falling over an edge. They'll generate that world, and they can take this person in VR and kind of work through this problem with them. I thought that was a fascinating use of generative worlds, and it's like one of the few so far examples, like what you just explained, that aren't just this like for film or for like video gaming. Like I'm so curious how people are going to creatively use it outside of the obvious use cases.
Yeah.
But like training is a big one for sure. So I think you mentioned briefly earlier, it's like the blending of things. It's not just going to be Gaussians.
Yes.
They'll take, a Gaussian creation, like a HDRI or a generative world, and then go in and model on top of it with meshes. So like I know I'm doing a podcast tomorrow with someone who has a VR company who does a lot of VR training predominantly, is what they do. So this would be like an excellent way for them to like be able to maybe create the exact in HDRI or a generative world based on some photos that this company's got a warehouse, right? And they're training in this warehouse, but they want their warehouse, not just a warehouse. It can be their warehouse with a few sets of images from their space, and they can create an HDRI of their warehouse and then put the VR training right there. So when the person gets there, it's like, oh, this is exactly like I trained. This is the exact look and view of where I'm at now. That was in VR.
This is the environment. Yeah.
Yeah, it's super cool, right? Which is just it
Yeah,
adds
exactly.
the realism in the training, right?
I think a similar one to this is also the other way around, where we are creating an environment and want to put in some real pieces from the real world. I recently spoke to one like 3D artist from like a 3D design studio, more like architecture visualization studio, and they were creating this visualization of like a new interior space for a restaurant and bar. So they basically wanted to renovate the whole thing, and part of the visualization was that they wanted to put in like a real world sculptures made by an artist from the US, and they wanted to ship those sculptures to the UK and put them into the space. They were like a huge sculptures, like a few meters by few meters, like a ginormous, like almost like one-to-one sculptures of horses, essentially.
I got you.
And the way that they did it, they created the whole environment for the whole like the restaurant and bar in 3D, but then they scanned the sculptures that already existed and just imported it into the model. This is what it's going to look like. This is the final look of the interior. So it can go both ways. You can create the environment and import in specific objects, or scan the environment and add specific objects as 3D mesh.
Do you know if these were? This is why I love this stuff so much, because it's so cool. Like you have the capacity to kind of blend like a like radiance with actual 3D modeling work, or you can go scan something with photogrammetry or LiDAR. Like there's all these methods. There's no one thing, and they all have their strengths and weaknesses. So it's really cool to see how these things all kind of like are playing with each other, and people are creatively using them to achieve things. It's like so fun. It's so fun to watch how creative people are with the technology as it is currently, and how it's already doing some really cool stuff. It's already solving problems in ways we've never done before, which is like the basis, I've always said, of any good tech, is that it's doing something better than we're currently doing, or in a way that we've never done it before, which is really cool. And that's why I love this space, because it's just offering up so many unique stories and use cases. And it's like every week or month, there's some cool story of like, hey, someone just used radiance for this. And you're like, whoa, that's really intelligent. Yeah, it's pretty fun. It's a fun time.
Finally we can use these things. Yeah. No, exactly. And I think we'll just see more of that. If you think that Gaussian Splatting came out only 2 years ago, it's crazy to think like how far it has already gone and how many tools we already have these days. So just imagine what is going to be like in 6 months, in 12 months.
Yeah, I think we're just like, I think we're really lucky as like tech guys to be living in a time where like the accelerants or the speed, of the innovation curve is just like going parabolic. Like we're living in a time where that's happening in multiple fields at the same time, and one specific field is actually making the other fields do it faster. Like AI is helping us make breakthroughs in all sorts of tech. So we're having this like wild curve of innovation and it's so momentous. We're living in like such
Yeah.
a cool time to experience like the ability to do the thing. They spend this like decades long building of all these different pieces, and it was like they're all almost there, and like now there's this like big curve up where everything's meshing together, and the like super crazy things are coming out of it and really fast, and like you're saying, oh, 6 months, whereas before there was like, hey, maybe 10 years from now we'll be able to use
Yeah.
radiance. It's like, oh, it's like we're doing it right now. It's super
Yeah,
cool.
no.
What a
Now,
time, man.
now is the time. Now is the time to start learning about it, and it'll be, by the time you know about it, it'll already be useful, and you can already use it for something. Yeah,
Yeah, I think and it's such a niche field too. There's not a ton of people in radiance. So if like this is something that, and I've talked about this with a few other people, it's like, if this is something that interests you and you're listening to this, like get into it. Cause like there's never been a better time for you to like become like somebody like really quickly. Like there's not like a ton of competition in the space. So like you can be a radiance person. If that's what you really want to do, like you can work up and make some waves pretty quick in the
yeah,
space. If you got some cool ideas. Same with AI, same with extended reality. And that's why I love these fields so much. It's why I love talking about them, and I love
yeah,
inspiring people by talking about them, so that they might go, oh, maybe I'll change my life path, and this is what I'm gonna do with my life now. Whereas like they weren't exposed to it previously. It's just such a great time to jump in if this is something that is really interesting to you as a career. And I don't know if do you have employees at Blurry? Is it just you, or
yeah.
you a solo?
It's mostly just me. I did outsource some of the work, but
Yeah.
I'm basically building this solo, which is another
Okay.
exciting thing. I'm not sure if I
Yeah.
would be able to build this solo without AI like a few years ago.
Yeah.
So it's another way that it just makes us more efficient and better and faster at building things.
Yeah. Yeah. It's great. If you're ever hiring, I'll send some people your way if they're interested in the space.
Yeah.
I always like to try to open up opportunities for people. So yeah, if you are, shoot me a link, and I'll start sending it out to the
I
network.
will definitely do. I do think I'll need some help very soon, actually. So, yeah.
It's great. I love it. I'm gonna plug some like recordings of it over us
Hmm.
talking. I think people
Hmm.
should definitely check it out if they're in the space. I know there's been some other interesting sites, movement in the space for that, like Post Shot, and I don't
Yeah.
know anything about it. I know nothing. I just know Post Shot is like a Gaussian Splat thing. And I
Yeah.
don't know. Is there something that differentiates you from other apps like that?
So you just mentioned PostShot. It's quite an interesting tool. It's really good tool to create your Gaussian splats, and that's basically where the idea for Blurry comes from. So
Oh, okay.
PostShot is amazing to create Gaussian splats. You get these Gaussian splatting files, but what do you do with them afterwards? Like, how do you share them with people? Like, if you share them with someone, they might also need to download and install PostShot to view it. They need a GPU, all that stuff. Or you can just upload them to Blurry and send the file like as essentially as a link, and they can view the Gaussian splatting model directly in the browser. But yeah, exactly as you said, right now is the time when new tools are popping up and new tools are being basically created for people who want to work with Gaussian splatting and nerves and neural radiance fields essentially. There is maybe sort of my competition, Supersplat, which is an open source project, amazing open source project for rendering and visualizing Gaussian splatting models as well. It's more difficult to kind of like edit and create like a really good viewing experience out of it and then share it. But the rendering engine is amazing and it works very well in browser. And there's like a few more out there. And I think we'll see even more of them over the next year. I think it's a similar. I think a lot of people have a similar realization that I had, because I tried to, actually, interestingly enough, I tried to build Blurry maybe 2.5 years ago, before Gaussian Splatting came out. I tried to build like the same idea based on neural radiance fields, but I never figured out how to render it in browser quickly and how to make them for like a reasonable price. It's like it was like very expensive to train them because you need to have a lot of GPU power to render them locally. You need to have like a very beefy computer, which most people don't actually have. So it was almost impossible to build it back then. So I shelved the idea for some time until the technology, until the research gets better, and until we have a technology where it makes sense to revive the idea and rebuild it again. And I think Gaussian splatting is the technology that will allow us to get there, to basically scan ginormous areas, maybe like a city-wide, like a city-scale 3D models that we create just from scans, and we'll be able to render them efficiently on almost any device, almost any consumer device, if I were to add that. So I think now is the exciting time to jump into this ecosystem and start building tools for people to use, because I do believe that this is the technology that will let us do all of these crazy cool things.
Is Blurry available on iOS, or is it just browser at the moment?
It's just browser at the moment.
Okay. Is that even, can you eventually get it to go to cell phone?
Yeah, I mean, like you can open like a Blurry link on your phone, and it will let you see all the models in your browser on your phone. That still works. But yeah, eventually it is possible to like build an app out of that. I think first I want to build like a really good app to create your experiences and then to share them with people. And then I will backtrack from there and build an app to also make the scans, make the captures, and basically cover the whole process end to end, if that makes sense.
Yeah. Do you want to like quickly like brief blurry.com? Or use blurry.com? I got it pulled up right here. I can. All right, cool. So we're in useblurry.com.
Mm-hmm.
So this is your homepage, and you're right here. You're already dumped into playing around with the Gaussian Splat. You can zoom in and out. So if you've never seen a Gaussian Splat, this is a Gaussian Splat. So someone, I assume, captured this with a drone?
Yeah. Actually, it was me who captured this. Like this particular model, I did with a drone. So this is like a small castle in like the north part of Slovakia in Eastern Europe, because that's where I am originally from.
Okay.
So I made a trip at some point, back home. And yeah, there's this like castle that's very, very close to my hometown. So I captured it with a drone. So yeah, that's on my website. And yeah, this is Blurry. And the whole idea of Blurry is that you can use it to render Gaussian splatting models in browser, and you can share them with anyone, and other people can view them in browser. No other tools needed, nothing that you have to install is necessary. You just go to the link and see the model exactly the same way you just saw the castle there. There are like few other neat features where you can just add annotations, add extra text or labels to describe your model. This is particularly useful for the professional training, as we spoke about before, where you might want to have a tool or equipment and you just annotate, oh, this button does this thing, this button lifts these doors, etc., etc.
Sorry if that came through.
No worries. Yeah, so that's what like Blurry is essentially about, and what we are showing right now is what it looks like inside the platform. This whole experience actually getting rebuilt and will be different in around 2 weeks' time.
So if they go to your site here, it looks like this is it's like a demo. This shows them how to like get started on Blurry.
Yeah,
and
exactly.
kind of like a general walkthrough. And so they just create an account and then just kind of like pay for like a storage, like how much they're going to need or how many experiences they're going to play around with, and just kind of go from there and play. Nice, super
exactly.
easy.
That's the idea. You can try it out for free. You can try out first few models for free. There's like a free tier, so no worries. And then you can pay to get more storage and more features essentially.
Nice. I think you built something pretty cool there.
Thank you very much. Yeah.
Again, I'll drop the links for that in the podcast notes if anyone wants to go to that.
I appreciate it.
As well as your, I'll add your LinkedIn. Is there any other links that you'd want to add?
I think LinkedIn is the main one. We can add YouTube, but there's not that many followers so far. Not that many subscribers.
Do you put out? Yeah, but do you put out educational content on 3DGS on there?
I do little like educational content on like general software engineering, general engineering, and computer vision and graphics, but I have not put out anything recently, so maybe we don't have to
Oh, yeah.
put a link to that just yet.
If you want to,
Yeah.
I'll send it over. I'll ping that in there, as well as
Yeah.
and we're reaching our hour mark here, so I always like
Cool.
to ask if you have a book recommendation or a website recommendation. Obviously, use blurry.com as one, or a person that they should follow that you think is super influential, that you think is great for on topic, I guess. But it also doesn't have to be on topic. If you have a book that you think is just generally great, people should know about, you can plug that here if you'd like.
Yeah. So book to read, there is no particular book that comes to mind. Like all of the kind of like a Gaussian splatting knowledge that we have has not been written in a book just yet. Like it's all so fresh. So it's mostly about like reading papers and reading articles. Definitely worth reading the original paper and any other follow-up that people might be interested in. Regarding books, I think it's becoming more and more relevant for anyone interested in AI in general. There is this like basically the Bible of AI called AI: A Modern Approach. I can send you some link afterwards to what the book
Yeah.
looks like. Essentially, it is the book that explains how not like how AI works, but what are the fundamental approaches in which to think if you want to build an AI. And then there's like a really good starting point and a really good like fundamental understanding that you can then use
Okay.
to go and read all the latest papers essentially.
So this would be like beginner, like maybe intermediate. Is it get into like deep technical details of like LLMs and all that?
It is fairly technical, so it's useful
Okay.
for people who want to pursue or are already pursuing something like a university degree in this direction. Doesn't have to be necessarily computer science, but anything in the STEM direction if they are interested. So it is fairly technical otherwise.
That's great. I love
Yeah.
that. There's so many there's so many extremes in books. You get either
Yeah.
it's like this very obvious like simple AI instruction book. It's like here's what an LLM
Yeah.
is, or you get like wicked math. Like you're like where's I just need I need the middle book. So that's nice that
Yeah.
sounds like it fits in that space.
It's always difficult like to strike the balance, but I do think this one is in the middle. It's definitely not like a nighttime reading, but it's also not something crazy difficult that you just
Gotcha.
like can't read at all. So yes, it's somewhere in between, and like offers really good like fundamental understanding of like how different AI approaches work, even those machine learned, even those like classical approaches that are not based on machine learning, which are still relevant today. And you also asked about people to follow. I believe you already had one on your podcast. Jonathan Stephans is a really great person to follow. I really like his content.
Yeah, great
Lot
educator
of cool
on the space.
Exactly, lot of good stuff on how to use Gaussian splatting, how to use nerves, how to work with computer vision, and essentially, he's very approachable way of explaining everything, which I really like. And another one is Bilawal Siduh, if you know him. I'll send
I
send
do.
the link after. Yeah. So another really cool person, really big influencer in the space of computer vision in general. So a really cool person to follow as well.
I reached out to him early. I didn't do a deep dive on him. I just kind of like breezed his LinkedIn. I kind of like came across him naturally. He just put out like an AI explainer video, and I was like, hey, I think he'd be a great person to have on the podcast. And I didn't realize at the time how big he was in the space.
Yeah.
He's like, call me
Yeah.
in a few years, man. Yeah,
Yeah.
Bilawal Siduh is a great follow if you like AI specifically. I think that's like predominantly the educational videos he puts out, but he does cover a lot. His breadth is wide in the radiance. He
Definitely.
covers XR and he covers AI, but he's a good
Definitely.
follow.
Definitely. And maybe one last one, but this one is way more technical. It's my guilty pleasure sometimes. Watch on YouTube. Three blue, one brown. I'm pretty sure you know him as well.
Yeah.
Really good educational content. But he has a lot of content on general like math, physics, and very recently also AI, LLMs, and all that stuff. So
Yeah, I think I've been
definitely worth
following.
watching.
I think I've been following that account for like, it's got to be like 5 or 6 years now. It's been a long-term account, and it makes like very, very approachable content. It's really easy to understand, but you come out of it with like a oh wow, like I really understand how that works now. It's
Yeah,
not like superficial. It's like it's great. It's always fun to come across someone who is very fluent in explaining very
exactly.
complicated ideas in a very simple way. But yeah, so those are great recommendations. Thank you for those.
Yeah, 100%. Yeah,
Well, thank you again for coming on
cool.
the podcast, Martin. I thought this was a fantastic conversation. I think we got into
Hmm.
some really cool stuff that we haven't really dabbled into too far into yet on the podcast.
Hmm.
I'm excited to, if you're interested, coming back in like 5 or 6 months from now to talk about the industry. I do have plans of trying to get together like 5 really interesting people in the space for radiance to come and
Hmm.
do like a roundtable podcast and just kind of let you guys go at it. If you're interested in that, maybe we could set that up and have you be a part of that as well.
I would love to, Cody. I mean, thanks for in the first place. Thanks for having me. I really enjoyed this conversation, and I would love to speak again. And also, I would love to meet with other people who are influential in this area. So definitely, if you are organizing something like this, let me know. I would love to stay in touch.
Sounds like a plan.
Cool, perfect.
Thank, thanks again, Martin. We'll catch you soon.
Cool. Thank you very much. See you later.
Bye.